Now in our Desmos, we were playing around with these algebra tiles, and we're given the first two parts. So we're given our x squared, which was our blue square, and we were given that 6x, so we had those 6 green rectangles. And we were trying to make a square from this. So we learned that when we had to make a square, we had to split up those 6x, and so we had 3x on each side. And then we had this corner up here, and we were looking to see how many single units were up there. In this case, we had 9 single units, and that's where this number really came from. And then if we looked at how it split up, we had this distance of x for that blue part, and then we had these 3 single units, so x plus 3 units, and we had a square of that, so we could write it as x plus 3 squared. So when we tried out other things, when we start off with x squared plus 10x, we had 10 of those green rectangles, and we had to split them up. So we're going to put 5 on each side. We'll put 5 along here too. Okay. And then we were looking to see what was up in that corner. So we want to know how many single units we would have here. So it's going to be a 5 by 5 square in there. So there's going to be 25 units in here. So we'd have a 25 in here. If I look at my dimensions here, I have x plus 5 rectangles there and plus 5. So those are single 5 units. So we have x plus 5. If we try another one here, this x squared plus 8x. So this 8x has to get split up. So we're going to put 4 of these rectangles this way and 4 this way. So now that creates this box up here that's 4 by 4. So we have 16 units up here. And then if we look at how much we added 4 this way, so x plus 4 squared. So these are going to be 2 equivalent ones. So if we look at the pattern of what's going on, what we did is really, we took this value here and we divided this by 2. And that gave us this number. And then we took this value and we squared it. And that gave us this value. So same thing here. We took this 8, we divided it by 2 to get this. And then we squared it to get the 16. So we're going to start off with those first 2. So we're using this to be able to look at how we can complete the square, or how we can write a function in our vertex form by writing that perfect square in there. Okay, so our goal here is to be able to look at this function, and we want it in this form of ax minus h squared plus k. We want that perfect square there. So we're probably going to have some number left over outside of the parentheses. And so we're just starting off with ones where our a value is just 1. And we're focusing on these 2, just like we did in the top. And so we're looking at how we can make that into a perfect square. So visually, I'm going to show you how we can do this first. So we have this x squared. And then we have these 12 x's. Now this is a negative, and so with algebra tiles, we do it with a different color and we flip it over. I'm going to do it in purple just to show something a little bit different. These are negative. So we're going to do 6 each way. Technically, it's really negative 6 each way. So right now we have this x, and then we have a minus 6. We have this x, and we have this minus 6. So we know that part of our perfect square. We know this part here, this x minus 6 squared. And then we're looking to see how many pieces that we're going to have up here. And so we had a negative 6 by negative 6. And really we multiply these together and we get 36. This is always going to end up being a positive value. Now we see this 10 at the end wasn't quite the 36 we wanted. So let me show you how I would do this more algebraically. So I really rewrite this and have the structures for it. So I write my function and I'm focusing on my x squared minus 12x. I'm going to group this and I'm going to leave a little space because I know there's an extra number that I need right here. And I'm going to push my 10 to the side. That 10 probably is not accurate. Now when I do my work here, I know I'm going to have this perfect square. So it's going to be x minus or plus some number squared. So I set both of these structures up. I haven't changed the value of my equation at all. I'm just setting myself up for success. So the first thing that we really did here is that in this diagram, we took this negative 12 and we divided it by 2. And that ended up giving us this number. So then we know we have this x minus 6 squared, this perfect square that's x minus 6 by x minus 6. Then to find out how many of those squares we'd have up in the corner, to find out what that missing blank is, what we did is we took this negative 6 and we squared it. And every single time, we're going to get a positive number from this. We got 36. Now we can see, and I'm using different colors to really point this out, now we can see that this is going to be different, like we've just added something extra in this equation. So to balance it out, what I'm going to do is I added 36 out, and I want that in that parentheses because this x squared minus 12x plus 36 equals x minus 6 squared. I need to write those equivalently. So to balance this outside here, I'm going to subtract 36. So I want that positive 36 in the parentheses, but I need to balance it. So outside, I'm going to say, okay, now I'm subtracting out here. And so I get a negative 26 when I combine that 10 and negative 36. It's almost like I needed an extra 26 units there to pull to make this a perfect square. So now this is in my factored form, or in my vertex form. And I can even find out what my vertex is. So it's the opposite of this value inside here, so it's a positive 6, but then it's the same as this one. Because if I put a positive 6 in there, this parenthesis group would be 0, and I'm left with a negative 26. So we're just practicing with x equals with our a value of 1, and we can do that more complex. So let me walk through these other ones, and you should be able to try to do these on your own as well. So for this one, I'm going to set up my structures. So I'm going to put this x squared plus 10x in parentheses. I'm going to push the 15 to the side. And then I'm going to write this in that vertex form with just blanks. So then I take the 10 and I divide by 2. So positive 5. Then I square it. So positive 25. And then I balance it, so I subtract it out here. Then I can combine these two together to give me a negative 10. That's vertex form, and my vertex is a negative 5, negative 10. Let's try that one more time. And really, you can try this too. You should pause this and try this on your own. So x squared minus 18x, leave a space, push that negative 2 aside. And then let's set up our structure. So we know that our answer looks like this. Now sometimes I see that squared on the inside of the parentheses, which is not correct. Okay, so we're going to divide this by 2. We're going to square that, positive 81. And then we're going to balance it. So we're going to subtract it over here. So when we combine that, we get a negative 83. That's vertex form, and our vertex is positive 9, negative 83. So it can be kind of a quick way to find our vertex. There are other ways to find the vertex too, but we're rewriting it in this equivalent form called vertex form. Take some practice, and then you should be really good at this.